Hi, I'm Uncle Sayed, a field engineer at Wallaroo. In today's demo, we'll explore how Wallaroo enables enterprises to deploy, migrate agentic AI workflows securely, at scale, and with a consistent experience across any environment and hardware platform. Whether in the cloud, at the edge, or on-prem, Wallaroo makes that process seamless across different combinations of environments and silicon, all while preserving the same streamlined workflow for deployment, inference, and lifecycle management. Wallaroo puts you in complete command of where and how AI agents are deployed, updated, and integrated. Let's get hands-on and dive into today's demo to see how. For today's walkthrough, we'll work in a Jupyter notebook, though the same workflow applies in any Python development environment with access to your Wallaroo installation. We'll begin by importing the Wallaroo SDK, a pip installable Python package that provides the interface for working with Wallaroo. Then we'll connect to our Wallaroo client and workspace to finish the setup. With our setup complete, we're ready to upload our open source LLM. For today's demo, we'll use Llama 3.1ab, uploading it with the help of the upload model function. To it, we'll pass a few key arguments, the model's name, and file path. The framework vLLM telling Wallaroo to optimize our LLM's runtime for it is as simple as passing it as an argument. Critical for agentic AI applications, optimizing our LLM for high throughput, low latency inference. Along with that, configuring the vLLM parameters is just as easy. We'll set the max model length to around 10,000, allowing efficient runs even on smaller accelerators. Next, we'll set the accelerator and architecture on which our llama will run. Because Wallaroo is silicon agnostic, this isn't just about configuration. It's about migrating inference workloads seamlessly across accelerators and architectures. By simply setting the accel parameter, we can move from NVIDIA's CUDA, AMD's ROCm, Qualcomm's QAIC, IBM's Spire, Intel's Gaudi, or another accelerator. Similarly, the arc parameter continues that paradigm to allow us to just as easily do the same across different hardware architectures. The best part is, Wallaroo comes with all the built-in dependencies needed to support this migration of agentic AI workloads and LLMs. And even with these optimizations and hardware migrations, uploading and preparing our LLM is done in a matter of minutes, often 10 or less. Once uploaded, in addition to our LLM leveraging our accelerator and vLLM, we can further optimize its throughput and efficiency by configuring and use continuous batching, maximizing our AI agents' performance on our hardware. Next, thanks to Wallaroo's OpenAI API support, we'll configure our open source LLM to use the industry standard OpenAI API, making it immediately compatible with existing SDKs and tools. Now that we've uploaded our llama, configure it for our accelerator and architecture, optimize its throughput and efficiency, and made it OpenAI API compatible, we're ready to configure our deployment hardware. This is where Wallaroo helps abstract away the complexities, simplifying how we configure our hardware, providing a consistent experience regardless of the silicon. With it, we're able to define the allocation of our deployment's resources, along with the amount of replicas, and if we'd like it to auto-scale. Wallaroo's deployment configurations strike the perfect balance between abstraction and fine-grained control. By allocating CPUs to handle data transport and local balancing, we're able to dedicate our accelerator entirely to our LLM, maximizing our llama performance and any optimizations such as continuous batching, allowing us to ensure optimal resource usage. Once our configurations are set, we can deploy our pipeline. We'll give it a name, add our LLM, and deploy it using our configuration. Wallaroo takes care of automatically deploying it to the correct silicon. Once deployed, we can retrieve our pipeline's API endpoint, which can then be integrated further into our overall agentic AI workflow. Using the API endpoint, let's try inferring on our pipeline. Because we configured our llama to be OpenAI API compatible, we can test it using the OpenAI SDK. We'll begin by making our OpenAI client using our pipeline's URL and our Wallaroo auth token. Once created, we're able to use both the completions and chat completions functions as expected. Thanks to Wallaroo's thorough integration of the OpenAI API, we're also able to stream the generated tokens. Along with deploying to the operations center, thanks to Wallaroo's publish function, we're able to distribute our AI agents as AI inference microservices, allowing us to deploy them anywhere. Publishing a pipeline creates a fully self-contained deployment, pushing its artifacts to our private container registry, which we can then take and run on distributed remote environments. Best of all, because much like uploading our model and deploying our pipelines with our tailored parameters, publishing our pipeline can be done in a matter of minutes, helping alleviate bottlenecks in the distributed deployment workflow. Also, thanks to OCI compliance, these publishes can be deployed using Docker, Podman, or Helm. Regardless of hardware platform or deployment scenario, Wallaroo provides a consistent workflow for deploying publishes, enabling distributed inference close to where requests originate.